Pure air, real vodka, zero grapes. Sounds fake. Stay watching. One man turned empty sky into drinkable alcohol. No fermentation, no yeast, no fruit whatsoever. Just carbon dioxide, hydrogen, and pure chemistry. Scientists said this reaction needed industrial factories. He built it inside a home laboratory instead. Everyone assumes alcohol only comes from sugar. That assumption is about to get destroyed. This experiment captures CO2 directly from atmosphere, then forces it through custom-built metal catalysts. 2 catalysts, handmade, engineered for one reaction. Iron for one step, copper zinc for another. Pressure hits levels most kitchens never see. Temperature climbs past 300 degrees Celsius. Inside that reactor, invisible gas becomes liquid. Liquid that smells, tastes, and burns like alcohol. This isn't science fiction, it's real chemistry, and it almost failed more times than succeeded. Multiple catalyst batches simply refused to activate. Weeks of troubleshooting before the first success. When it finally worked, something incredible happened. A single drop formed inside the tube. That drop meant air had become alcohol. By the end, he tastes his creation. What happens next changes how you see chemistry. Here's exactly how he pulled off air to alcohol. Step 1 starts with ordinary sodium hydroxide pellets. This chemical grabs moisture straight from open air. It also traps carbon dioxide molecules simultaneously. Slowly, the pellets transform into something new. Sodium carbonate crystals begin forming inside the container. Each crystal locks captured carbon dioxide tightly inside. This isn't magic, it's basic acid-base chemistry. Sodium hydroxide reacts. CO2 disappears from the air. But the carbon dioxide isn't gone, just hidden. Now comes the tricky part, releasing it back. Controlled heating breaks the carbonate bonds apart again. Pure carbon dioxide gas escapes, ready for reaction. This captured gas becomes his raw building block. Essentially, he's mining alcohol's carbon from thin air. No oil wells needed, no industrial CO2 tanks. Just chemistry pulling carbon straight from atmosphere itself. This single step proves air holds hidden resources. Now the real transformation is about to begin. Capturing CO2 was easy compared to what's next. Turning gas into alcohol needs serious catalytic power. He builds a custom high-pressure gas reactor system, every component engineered specifically for this reaction. First catalyst, iron, chosen for its reactive surface. Iron helps convert carbon dioxide into reactive intermediates. Second catalyst, copper, zinc, and aluminum combined together. Potassium gets added as a crucial promoter chemical. This CZA catalyst pushes intermediates toward forming ethanol. Making these catalysts required precise chemical engineering skills. Wrong ratios mean the entire reaction simply fails. Both catalysts need activation before they'll even work. Activation means exposing them to specific gas conditions. This step alone took multiple frustrating attempts total. First tries left catalysts inactive, completely useless chemically. He had to redesign and upgrade his system. Every failure taught him something about catalyst behavior. Eventually, both catalysts activated exactly as needed. Now the actual transformation moment finally arrives here. Captured carbon dioxide meets hydrogen inside the reactor. Pressure inside climbs to genuinely extreme industrial levels. Temperature reaches 320 degrees Celsius exactly. That's hotter than most home ovens ever reach. Under these conditions, molecules start rearranging themselves completely. Hydrogen atoms bond with carbon from captured CO2. Slowly, ethanol molecules begin forming across catalyst surfaces. This reaction pathway mirrors real industrial synthesis processes, except it's happening inside a homemade reactor system. Gas flows continuously across both specialized catalyst beds. Minute by minute, invisible gas converts toward liquid. Finally, condensation appears inside the collection chamber tube. Liquid droplets, actual physical proof reaction succeeded. This liquid contains real ethanol, made from air. Not simulated, not theoretical, genuinely present, physically real. Months of failed attempts led to this exact moment, but raw product isn't finished alcohol just yet. The collected liquid needs serious purification before anything else. Distillation separates ethanol from water and leftover byproducts. Heat vaporizes ethanol, leaving unwanted compounds behind completely. Activated charcoal filters out remaining unwanted trace chemicals. This step removes odors, particles, and unwanted contaminants. After purification, testing reveals something genuinely surprising here. The solution contains roughly 7 to 8% ethanol. That's comparable to strength found in some beers, but trace methanol still lingers within this mixture. Methanol contamination makes this genuinely risky to consume. Despite the danger, he decides to taste it anyway. Just a small, careful, deliberately cautious first sip. His verdict: clean flavor, sharp, genuinely unique taste. Not exactly vodka, but unmistakably real drinkable alcohol. Alcohol that started as literal air, nothing else.